Alright, welcome to another video, and in this video we will be looking at Seaborn for visualization. In the last video we looked at Matplotlib for visualization, and in this video we want to look at Seaborn. Like we said right from the start, Seaborn is built on top of Matplotlib, right? Just the way Pandas is built on top of NumPy. So you'll be seeing PLT again in what we are doing. So we import all our libraries first, and then we can do what we want to do. So Seaborn is built on top of Matplotlib. It provides high-level interface for drawing attractive and informative statistical graphics. Don't worry, leave the grammar. It works seamlessly with Pandas. So what's just a quick difference, for basic charts we can do that, but for more maybe statistical stuff and advanced, and it has beautiful customization as well, so we can use Seaborn. But let's leave all the English. I just have to put that note in case you want to read, have an idea of what you can do and all of that. So import our libraries, import libs. So I'll say import. Now it's always good to just import Matplotlib. The same way when we want to use Seaborn, it's good to always import Pandas. Sorry, when we want to import Pandas, we should always import NumPy. Yeah, that's what I mean. So then you import Seaborn as SNS. That's the general convention. By now we're used to alias, so I've been using it since the time of NumPy. Okay, so we're importing this as SNS, and we want to say Matplotlib inline, Matplotlib inline. So we'll execute that, and okay, good, we're good to go now. Now one beautiful thing about Seaborn is that it has inbuilt data sets, and we can get to see all the data sets we have in there, because for this particular one I already planned I was going to use the airline data set. In the last video for Matplotlib we used an automobile that we generated automatically, but let's see the data set we have inside Seaborn, which you can also now use to further explore yourself. And do not worry, as usual you'll be getting a full hands-on exercise after all the visualization tool or all the visualization libraries we want to explore. Okay, let's do set get data set name. You can see the name, you can see the option here. So we can say run this, and you can see we have anagrams, etc. all the way. The favorite, the famous Titanic dataset is in here. Tips dataset is in here. This is also in here. This is also in here. They are quite famous. You know, you have as much. You see, you have car crashes, you have brain networks, etc. So feel free to get any of these datasets. So how do we grab one of these datasets for ourselves to use? You can grab it by doing can just say df, all right, because this is another one. So I just say df df SNS. So am I doing pd SNS dot, and we have the option for load datasets, and major thing we have to pass is just the dataset name. So in this case we want to pass in flights. So we're going aviation this time, and then we can say df.ed. So see what we grabbed. All right, so it only has 3 columns: year, month, and passengers. All right, year, month, and passengers. That is all that it has. So for us to use the bar charts or the line chart first, oh, the sound, I really hope it's not interrupting. So for us to use the line chart, we just want to do passengers trend, passenger trends over time, right? We'll see the PLT method with what's it called, with this data set, right? And then we'll see the AX or the axis method with it. So this will be very fast. If you have not seen the previous video on Matplotlib, I would strongly advise you go and see it. So don't forget that this is built on top of it. So we still have our figure, plt.figure. Then we can open this and then pass in our fig size. All right. So our fig size will be passed in as a tuple, and then just say 7,4. Okay, that's figure. All right. What else do we want to pass in? Then we'll say SNS now. This time we call SNS. Now for Matplotlib, we have been using dot plot for a line chart, but here it is a line plot. So it's just little difference. And of course, you can always go to the documentation page. Just search on Google official documentation page for Seaborn, and then you can learn a lot from there yourself. Okay. So we're passing in a line plot, and we want to say passengers trends over time. And for the passengers trends over time, we have the year, month, and passengers. So we can just say passing our data. Now this one takes the entire data set first, right? Unlike Matplotlib, we're just passing a column or columns that we want to use. So it takes the entire data set first. So I will say df. Then we can say x-axis. You can see it makes it easier to work with. So we can say here, instead of, since we have passed in the full data set, we can just pass this in. Hope it's spelled the same way here, all lowercase. So x-axis, and then we can just do y-axis, which should be passengers. So that's as simple as it is. So color, you can say crimson. Okay, then put that in single quotes, just like that. So let's run this. Oops, I forgot a comma. Okay, right, that's correct. You can see after this, it said I forgot a comma. So that's a syntax error. So it's loading. Oh, you can see how nice that is. We're getting a line chart. And in this case, you can tell that we don't need to put X label and Y label again. X label and Y label, it came with it automatically. Why? Because we didn't pass in the entire thing. It just picked it directly from here, which is very, very nice and cool. So, but however, we can pass in the title, and for us to pass in the title, we use our plt.title. We don't use xns.title, right? We just do plt.title, and we can say this is total annual passengers growth trend. And of course, from our data set, you can see we have different year and number of passengers. So from the beginning of the years, so far the airline has been experiencing a growth in number of passengers. It keeps growing and growing and growing on an upward trend. So let's add the title. And you can see how clean this looks like. So for any other customization, you can just use your PLT. So if you want to use the axis method, by the way, we're just going to do it for this one. We're not doing it for the rest. So we'll just use the axis method for this. We're not using it for the rest. So we'll do our usual fig ax. Then we want to do our subplots, since we just want a single row column. Don't want all of those fancy things. We'll do fig size. Okay, fig size. Tuple. Say 8x4. So the next thing I want to do is I think I'll just copy this. Yeah, this entire thing. Control C. Now come back here. Control V. And you're probably thinking, if we're doing it this way, then like what's the point? Let me copy the title as well. what's the point of using axis? Do not forget that the point of using the OOP method is so that we can have multiple charts on a single line. But then you're now saying we're using it the same way. How do we pass in individual axes? So let's say, for example, we specified 5,5. So in this case, we can just do axis 1, axis 2, axis 2, axis 3, all the way like that. Remember, unpacking, we can do a full unpacking for each subplot. And if we do that, or we can just grab the subplot alone, and then or we decide the size separately, then we'll do the subplot, and then in here we pass in one more argument that tells us the axis to use. Now, which of the subplot axis should we use? Then we can say axis equals to ax, and of course here, if we have any stuff, if we didn't unpack here, we can just pass in our values right there. So in this case, we just say ax. That's ax1. Let me take that one out. So this is how you specify that this is what we want to use. If we have different subplots, we'll pass in a square bracket, and then we specify. So let's say 0, 1, or whatever it is that we want to use right there. So, but in this case, we just have one, right? We just have one. We have not run this cell, so it doesn't know what the ax is. All right. So yeah, let's run this. You can see what we're getting. See, literally the same thing, no difference at all. And you still remember how to save? Just do plt.savefig, and you get your data saved right there. So let's look at the bar charts. Just look at all of these charts quickly, and then we'll wrap Seaborn up like that. So we want to see average passengers by month. Average passengers by month. So we can do our fig. So going forward, I'll be using the fig. I'll not be using the PLT again. So 8x4, we want it that way, and then we want it to be, just paste it inside there as well. We might need another code cell, I'm not sure yet. So back here, we have our axis defined. Then we can say sns.barplot. Then we'll open this. Then we'll say data. As usual, our data is what? df. X is month. Y is passengers. And finally, we can pass in these are just spice. I'm passing templates. You can read more about it on the documentation, and do not forget to pass in our axis to what the ax axis, because that's what we're using. Then we can say title, sns.title will be average passenger traffic distribution by month. Okay, sorry, I'll have to use ax.setTitle. All right, just like that. So everything should be fine. Okay, I use the PLT version up there. So since we're using the ax, we continue using the ax.setTitle like this. So let's run this and see what it looks like. It says ax. Oh, okay, that's ax dot set underscore title, right? Okay, so we can see how nice this is. You can see the color palette is giving us some good vibes. So you can see for January, for February, for March, all the way to December, right? It's as simple as that. In this case, I'm not doing the interpretation with you. Just take your time, think of what does this chart mean. I just want to show you how to plot the charts. So next one, which is for the distribution, right? Right, which is a per year thing. Want to do observations per year. Here we can do, we have already specified this. So I think I'll just copy this guy again. Control C. And I'll keep it down here. Then I can just copy all of this because it seems like I'll reuse them. Okay. So SNS dot count plots in this case. So we have count plots, and then we want to do get out of there. So come inside there and do our data as usual, df, and then x is here. So you can see Seaborn makes it easier to work with. And then we'll do a palette. I think I spelled palette wrongly already. Okay. Palettes. Rocket. AX. Right, that's all. Then we can say data record consistency per year. All right. So you can see what we have. So the count per year, palette missing value without assigning EU. Okay, it says next time we have to assign EU, assign X to the EU and set the legend false for the same effect. So we can just do that. EU is equals to year, and then we can pass in legend to be false. Okay, the warning is gone, so you can see, but one legend in this case. So you can see how nice that is working. So I've passed in that, which looks much better. Okay, on to the next. I want to do a scatter plot, which is just to check the number, the year, right, and the passengers by month, right. We'll do the year and the passengers by month. So I'll just change this to say 7. We'll call SNS as usual, and then we'll say scatter data equals to df x equal y equals, and of course our U applies a continuous or categorical map to the other features, right? So now the word feature, variable, columns, talking about the same thing. Okay, so keep that in mind. Then we can say U equals to, I'm just trying to create a skeleton of it, so Control C, just paste in here for reusing. All right, so x axis in this case will be our year, y axis in this case will be our passenger, and the U will be the month. Okay, so our title in this case will be monthly passenger, right? Monthly passenger distribution over the years. Okay, so before we run this, we want to pass in palettes as usual. Come up, come up, come up. Okay, just type it in full. All the arguments I'm passing, you can just check them online. Say ax equals to ax, nothing serious. So run this. Yep. Getting connected. Just wait for that to connect. Runtime disconnected. Let's run that again. Okay, so it's saying we are not getting. Okay, so that is scatter plot, not scatter. So hard plot. Then we run that. So it's connecting. Let's wait for that. Okay, it's still empty. Let's see why it is empty. Just stay here. So let's see why it is empty. So it's saying, oh, could not interpret value for okay, passengers. That should be plural. Okay. So because we do for individual years, that's why we're getting this, and it's just going upwards, 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 right? It's just going upwards. In this case, we're not creating a sample or anything. We're just saying for individual years like that, and it's showing us for each month. Showing us for each month, all the way to the top like that. All right. What else do we want to see? Let's customize the legend. Let's do a little custom application. So we have the option for AX legend, where the legend is. So we can say I think it's box to anchor, box artist, no, box to anchor. Okay, yeah, should be box to anchor. We'll pass in the tuple, and then we'll say, just pass in some figures right there. Then location, I want it to be, I think it's good in the upper left where it is. So upper is good on the left. So upper left. Is there any other thing? Nothing. Left. Where's my left? Okay. So it's just to take it out of the way of our visualization, right? So we're just saying out of the box to the left. We're just passing some simple figure like that. So you can see that our legend will not be a problem anymore. We can see our data properly. Okay, what else do we want to do? This is scatter plot. So we have histogram. We're almost done. Almost done. It didn't take long like the Matplotlib. Yeah, because the Matplotlib was the foundation. So yeah, that probably took long. So right here, I can just copy this as usual, hoping we will reuse it. So I'm just paste in here, paste in here, paste in here. Okay. So don't have to worry about retyping everything. So for the histogram, so we want to see the traffic size distribution. I think I'll just leave the figure the way it is, 7,4. But this time I'll say east plot. East plot. And then data is DF. X-axis is passengers. in this case is an histogram, so we'll say beans. You can say 15. KDE, that'll be true. It should go out there. So what else do we want to pass in this case? Want to pass in color. Take an hue, pass in color. Let's use orange, or okay, let's use a dark orange. Dark orange. And finally, as usual, axe. Okay, so you can give it a title. Frequency distribution of flights capacity. Okay, so can I hold on a minute. So the KDA is what I was KDA, which is kernel density estimation. It's just smoothing of our data. Let me remove it for you to see what that looks like without it. So you can see we're not having a direction, or as it were, it just has that nice smooth line for us. So all right, of course it's more than a nice smooth line, but let me just keep it like that for now. So we have seen the distribution of the data. So let's jump into heat map, and then after the heat map we will wrap it up from there. So for flights, say flight matrix, then we can see df. So we can use our pivot table, remember. Pass in the index as month, pass in the columns as year, and then finally we'll pass in the values as passengers. Okay, so this is what we have, and then we can take a quick peep into our flight matrix. I forgot a comma. Okay, after year, the syntax error. Okay, double equal to. Okay, so you can see what we're getting back. We're getting individual year, and we're getting the month. So this is a matrix, right? We're getting the month, and we're getting the year. All right, so let's pass that into our what's it called, our histogram. So we have our figure size. Let's do 8 by 5, a little bit bigger. Then we'll do its map. So passing flight matrix, annotation, that's true. Passing FMT, that will be our D C map. No, C map. What can we pass in here? Okay, let me think how's it spelled again? I think it's something like this. Yeah, this. And as usual, we're passing our ax. So we can say flight passenger growth density. So it maps let us see all of this number without having like a chaotic uh, chart, not a bar chart. So it just shows the higher shade or the darker the shade, the more we have at that particular point. So that's just nothing serious. I think we can run this now. So you can see the darker the shade, the higher the value, and you can see the legend right here. So you can see. So I think July and August was where we had 1959 and 1960 was where we had the highest number of flights easily, like that. You can just tell easily. And the list is towards the beginning, so it was a growth, right? It was getting darker, but somehow early months are not, we really don't have passengers flying early months, but somehow towards the middle of the month, but then it starts spreading to early months after, I think, let's say 1955, 1960, 1956, all the way like that. Yeah. So to wrap this up, I believe this is the last one. We have pair plots. Let's also look at passengers range for each year. Of course, it's as fast as possible. 8,4. Change this to a box plot. Of course, all of these charts will be to answer a particular business question. Or want to see this by this, want to see this by this, but we already have the foundation of charts. If you have not, I guess I'll have to leave a link in the description below for you to see the fundamentals of charts, understand the basics, why we use them, and what we have in mind for them. Okay. So, so for the box plots, let's take this out. 8,4. Then we'll grab this and box plots, df, pass that in. So the next thing is the year. Pass in the year. Y-axis will be the passengers. Pallets this time, let's use, I'll take this out, so just say palette. Let's use set 3. I think should be capital S there. Yeah, set 3. And axis, as usual, is supposed to ax. So the title here will be annual flights capacity. Annual flight capacity. Let's put some English right there. Variance and spread. Variance and spread. Okay, so we'll take all of this out. And then we'll execute that. Okay, so we can see for each year, we have been able to get the box plots for individual year, just like that. So the last thing we want to look at for Seaborn is the pair plots. And from the word pair, you probably have, or you're already thinking about what that would look like. So let's jump into it. For this, set the fixed size. Let's remove this fixed size completely. Then we'll say sns.pairplot. We'll pass in our data. Just pass in df directly. passing you as month, then palette is this way. I think this is Viridis. I think it's a Viridis. Yeah, it's pronounced Viridis, or however it's pronounced. So title, what title should we give for this? I'll take this out first. I'll take this out completely and then just execute first. So we're getting a pair plot, and a pair plot just gives us for the two variables that we have, the year, the month, and the passengers, right? So that's what we have. So we have the year against the year against passengers, then we have passengers against year, passengers against passengers, and you can see we have a distribution and we have a correlation option as well. Now if the data set is much larger than this, we will be getting quite a good number of what's it called. So what does pairplot do? First of all, it's checking if there's a correlation between the year and the passenger, and from what we can see, it seems like there's a correlation because it's tending upwards, and it's also showing us the plot, the distribution of the data set as well. So yeah, that's it. And I think with this, I can say we've come to the end of Seaborn. So far you've learned Matplotlib, you've learned Seaborn. Now your exercise for this is to explore another data set. So remember, if we go back up, if we go back all the way up, so you can see we have quite a number of data sets. You can explore car crashes. So explore with car crashes, work on it, carry out some visualization, share the link to your notebook in the Telegram channel. The link is in the description below if you're here to join. So share it, and then your work can be reviewed. You can share with other ones. You can come up with other insights and ideas that can intrigue other data professionals and enthusiasts in the group. All right, for that and more, I'll see you on the next video. Hold on. So I'll see you in the next video. Till then, keep practicing, keep practicing, keep practicing.